So again, this is Rohit Sharma, and we are going to present how to put AI models on tiny devices like Arduino or Raspberry Pi, even your mobile phones, and run them at a speed with low power. So that's the topic of this entire course that we would go through. And this is about me. I have worked for over 20 years for several companies, including Texas Instruments, Magma, Apache, Cadence, Purpat, and now I'm working for AITS. My social handles are given on the screen, so if you want to reach out to me on one of those. I'm generally active on LinkedIn, but I do follow rest of them once in a while, like every few days. I also teach a master level course in CSTU on machine learning. So some of the slides are actually basically taken from there and added the additional content for IoT. So this is what we're going to do in the next 6 weeks. So we would learn machine learning starting from Python. And that would cover most of the material needed, starting from basics, like covering Python, and all the way to how to compile and flash or download the model on your device. So these devices are very tiny and can be purchased under $5. And nobody, nobody practically is thinking or working on putting those models on these tiny devices. So we are first company of its kind that has developed MCU compiler from scratch. And for those of you curious minds, you can search for DNN compiler in Google, and GitHub repository will show up. And I'll show you that repository after I finish with my slides. So we'll start from Python, introduce popular frameworks like TensorFlow or PyTorch, and we will go through some of the theory and statistics on linear algebra. It's not required, but it's good to know what you would be getting into. We'll use Python for programming, and once we are done with all the theory and the support work of using our lectures, we will work on AIoT project for the next 6 weeks. So next 3 weeks in 6 lectures. So the first 6 lectures are covering the theory that is needed to apply your knowledge, AI knowledge, to work on gathering the AI knowledge, and then the last 6 lectures would be on how to apply that knowledge to get to smart hardware in your hand. And then you can go show off around to your friends and family that this is what I did. And that will be unique. There'll be something to be proud of. We'll use popular tools like cAInvas and lots of online and offline discussions, right? So brace yourself. It's going to be fast-paced, would require good amount of learning and dedication from your side. We are here to help. And hopefully after 6 weeks, you will have something that you can be proud of, including a component that's a hardware device, which you help make smart, and a certificate from AITS. And also, we will culminate this whole thing into a summit. So you would end up writing a paper about what you have done in the last 3 weeks. And that paper would be submitted to a summit that we will hold late September or early October. And so that's the idea. And in the summit, there would be industry luminaries and big marquee names. Like last year, we had a similar summit. So that's the long and short of this course. And we are hoping to give you something. Hopefully you guys learn and do something exciting. So this course is not part of any university yet. So we actually are also collaborating from universities and making this an UGC approved course. So if you happen to be in India and working for a UGC approved university, you would get credit for this course. But details are yet to come. They will emerge eventually in the next week or so. More details. The thing to pay attention here is we would, award some kind of a grade by the end of this course, and this would be the breakdown. So discussion 10%, quiz would be 20%. You would write a blog, that would be 10%. Final project that you would work after third week would be 35%, and you would present that after the work is over. That will be 10%. Write a paper, 15%, and total of 100%. So this whole thing will take you on a journey from Python all the way to having a component which is smart in your hand. So if you would like to, let's say, design something exciting that there is no product for, or you want to start a company with the product, you will have enough knowledge to start that. So for example, smart thermostat, like there are a lot of companies offering that, but let's say if you choose to create the board, the technology behind the smart thermostat, you will have everything under your belt to start the new thing. Or you want to start something new. For example, you want to start a new component, say electrical switch that listens to your voice. For example, you enter the room and say, hey, fan, turn on speed 3, and it does it without you touching anything, which is kind of required in this COVID era. So you would learn everything, how to do that and get to the component, put that in the switch, and you would have a smart switch in your home that nobody would have, because there is no product like that, right? So you can go with that product idea to one of the incubators or accelerators in your university or outside, and get started on a company. The point here is we are doing something very ambitious, and hopefully you would benefit from learning some of these technology and put that to practice. With that, let's get started. So let me give you a little bit of a historical perspective of how did we come to Industry 4.0, and what's the what is the how AI is affecting Industry 4.0. So Industry 1.0 was with the invention of steam engine that was running mechanical facilities with the use of power and steam, water and steam power. And that helped automate and start the transportation from one place to another. So there was a lot of nationalized movements in many countries that connected many places. And the economy before that was intensely local, meaning you grow here, you produce here, you sell here. And once the engine and railroad came, it kind of nationalized the economies, because you could connect and transport your product from one place to another. So that was Industry 1.0. 2.0 came about when electrical power enabled the work sharing mass production. So electricity by itself was not much of an innovation, because you couldn't do much by sending electron from one point to another. But the applications of electricity were enormous. And it's hard for you to imagine your life without electricity today. In US, it's rare that electricity or we lose power. Once in a while we do, and that reminds us our dependence on electricity. So it has become a ubiquitous part and kind of invisible part of our lives that we have come to depend on. And the Industry 3.0 started early on with the advent of electronics and semiconductor industry. That also is part of our lives without us realizing how much dependent we are. For example, if you look at your cell phone, it has a ton of semiconductor inside. And if you're sitting in a car, there are 50 microcontrollers around it. In a typical household, you will have additional 20 to 50 microcontrollers in every electronic device, starting from, let's say, DSL camera. You have a DSL camera, it's an optical device, but has a microcontroller and image sensor inside it. Anything Like, for example, you have TV, remote, or a refrigerator, or a washer, or a dryer. Anything electronic would have some kind of a semiconductor device embedded in it. And most of them are very tiny, very low power devices. And those are the devices that we are talking about. So when you hear about AI, Industry 4.0 and AI, it's essentially people talk in context with developing AI models for large machines, on large machines. And powerful servers, including accelerators like GPUs or distributed computing, and other accelerator types like VPU, NPU, and you name it. So anything that is tailored to process a large AI network. Now, what we thought in 2018 that these models could be made small, and now it's a challenging task, and with the reduced precision and reduced accuracy, like you reduce 2% accuracy from 98 to 96%, and all of a sudden you can run the model on a tiny device. With a basic processor of 40 megahertz, 50 megahertz, and a RAM or memory of about 256 kilobytes, and I repeat that, kilobytes, it's possible to run a 5 to 7 layer neural network on that tiny device. Now, people were laughing back in 2017-18 on the idea, but slowly they've started listening, and now we are ready to sort of float that technology that you would see next 5 years will become part of everybody's household. So in a way, AI is a new electricity. By itself, it's not much, but the applications thereof is something that you can expect that the world would change because of that. Our lives, our daily habits will change because of that. And so AI is becoming central tenet for the disruptive changes that are coming on, right? If you are in software or not, or using some kind of software, so every medical science, every science today has some kind of application that runs using software. So whatever kind of software engineer are you have to learn AI and you have to learn how to use it effectively, because if you don't, software 2.0 would have part of AI in the daily routine. So you better start today, start now, learn part of it, and ready to use when you come in the workforce. So what is artificial intelligence? So this is a slide that does not exhaustively cover the entire domain of AI. It's just the part that are popular today. So AI is essentially, artificial essentially is many branches, including machine learning, which is what is very popular today. And within machine learning, you have deep learning, which has become part of household vocabulary in the last 8 years. And you have all kind of neural networks, starting from convolution neural network, CNN, recurrent neural network, RNN, and their derivatives. We would focus on machine learning. There would be some algorithms in machine learning, and we will mostly focus on deep learning because of the usage of that, and the ease of use of DNNs, because it does not require you to create feature sets. So with that, the anatomy of an AI application is essentially three words. It was the definition that was given by Arthur Semmel in 1959. Essentially, it's a program that improves over time and learns without guidance. So what that means is you write a program today, and the same program runs tomorrow and the day after and the next week and the next year without any change, and you feed the new data. So new data to the same program, it generates a new model and it has learned new things. So the behavior of that program will change based on the data. And that's exciting. Why? Because we are actually data generating machine today. Like it or not, in our daily work, daily household, the kind of devices that we carry, is generating ton of data, and that data has been useless so far before deep learning came along. But then, if you just to give you an idea, every minute on YouTube there are approximately 400 years worth of video that gets uploaded. So that comparison is phenomenal. Just to give you an idea of how much data are we generating as human species. So that should need to be put to use, and we need to learn something out of that to make our lives easier. And deep learning fits in to the central principle of that that idea, and that's why it's very exciting. So the main idea that deep learning is catching on is because we will generate more data in the future, and you don't have to change the program that you write today. Just feed in more data, and it becomes smarter over time, as opposed to traditional software programming where you need a software programmer or a developer sitting on the program continuously improving it over the years to give you better results. So that's the reason deep learning has exciting repercussions. So with that, how do we create machine learning or AI apps? So the first step is you create the data, or you actually acquire the data. Either you create it, like for example, if you want to do a facial recognition, you will take a few pictures of your face, and that becomes your data. And then you do EDA, which is data analysis, exploratory data analysis on that. There are a ton of other ways to improve your data so that it is adaptable to the neural network. And once you have the data available, you design and train the neural network model or a machine learning model. And that would be another cycle that you keep going until you get the accuracy, desired accuracy. Once you have the desired accuracy, you validate the model. And once you're done validating, you're happy with the model, then you go deploy the model. And at any time you have newer data or sizable data coming on that you believe would improve the model, then you go back and repeat the cycle again. And there doesn't have to be a human in the loop, but typically today, because deep learning and machine learning have this notion of non-explainability, that is requiring people or human to intervene in these steps to make sure that whatever model has learned is doing the appropriate thing, and there are no side effects. Yeah, so with that, on this slide, if you hear or listen to media, you will hear some interesting things which have no basis whatsoever. And it's not all bad, but most of the time it's just things that are not true, or at least taken out of context, or have been written without understanding as to what the technology is. There is no blame here. We are not blaming reporters or journalists. It's just that when you have three people talking about the same thing, there are stuff there would be key concept that gets lost in the translation, and that actually creates hype, and that's what we are going through. My personal favorite, and some of those things, they actually become true over time. For example, in the movie, for those of you who have watched Matrix, that came in 1999, almost 21 years ago, Mr. Anderson would sit in a chair, and there would be some kind of electrode that goes in his brain and teaches him, transports into another world, and they train, practice, and all of a sudden, in few minutes, he's an expert of flying the helicopter, or kung fu, or any other art. So that was the idea, and that idea is coming to sort of has promise of becoming a reality in the next few decades. There is a company that is funded by Elon Musk called Neuralink. They are trying to sort of communicate with human brain. And so there is a microcontroller sitting on that chip, which would be connected to your nerve cells, and eventually that will talk to your your brain. Whether it can train or transfer the learning is not very clear as of this moment, but that's what they're working on. So hopefully next 10, 20, 30 years it becomes a reality. That's the hope. And these ideas, they actually come from these movies that are baseless at that time, but then they plant a seed of a thought that becomes a reality in future. And again, these popular guys, these famous and rich guys, are taking one side or the other. There is Elon Musk's side, who's saying that with AI we are summoning the demons, and then there is a somewhat optimistic side that we should use AI and uh, put more investment and research into it. And I'm on the most optimistic side. And the reason I say that is that with every new thing that shows up on the horizon, people are fearful. And that fear is basically rooted in fear of unknowns, that you don't know what we would end up doing with that technology. And like 100 years ago, when Alfred Bell came up with the idea of hydrogen bomb, he didn't know, he'd never imagined the kind of ways it would be used, the technology would be used. And so right after, within a couple of years, he realized, and he started this institution called Nobel, and that is distributing Nobel Peace Prizes after that. So sometimes there is a mistake, but most of the times it's just you have to learn how to keep a control on that technology. I don't want to go into the sideways, but the idea is that this is very exciting. And what we are doing at AITS, we have developed a technology that would power companies like Neuralink. So you can create a model and put it into a microcontroller, and the applications are infinitely exciting. So believe that what we are presenting today is something out of the ordinary. And once you learn how to put a model on a microcontroller, you can create a component or a device or start a company or make your house beautiful or unique, number of other things, or just go around, show off to your friends. That also is a in my mind, a good objective. Or go show off to your employer, right? So this slide shows the companies that have started in the last 18 months. There is a number of billions of dollars that have been poured into these newer companies that have showed up on the horizon, starting in machine learning. Consumer apps, you have seen some of those. Voice assistants we all use today. Autonomous car is fast becoming a reality. Journalism is using AI. You name it. I mean, every branch of science and art is using AI. Even painting. So there was a painting that was sold in New York 2 years ago, sometime in 2018 October, for about 5 million. That painting was created by a neural network called GAN, Generative Adversarial Networks. Took them a long time, but it was purchased for 4.7 or some obscene amount of money. In the ML verticals, the AI verticals that are coming on, they are also huge. And this slide shows some of them. Not an exhaustive slide. It's definitely more than 100. If it's touching 1,000, I wouldn't be surprised. But any market, any vertical that you can think of that is being made smart, typically would use some kind of an AI or a machine learning model. Why now? Well, there are a lot of reasons. So why AI compute is coming to edge is essentially, if you look at vision AI. So on this slide, you see the number of image sensors that are being produced just in 2020 alone, which is this number. The number is about 8 billion, and that's more than the human population on the planet Earth. Now, we are producing 8 billion image sensors. That is more than one image sensor per person. Why is that comparison important? Is if you assume the average life of an image sensor as 3 years, on the average, we are carrying around 3 image sensors per person. And if the data that is produced by those image sensors, the data rate is about 10 to power 20 bytes per second. That is 100 exabytes per second. So that is 1 followed by 20 zeros. And if you look at the bandwidth of internet today, it is about 45 gigabytes per second. That's 9 zeros followed by um, uh, 8 zeros followed by 45. So the comparison of these number of zeros is of the order of more than 10, and that would take us about 30 years to catch up to a point where we have enough bandwidth to consume the data that is generated by these edge devices, right? So either we wait 30 years or we find a solution, right? So the humans are good at finding solutions that are imminent, and so the solution is that the data must be processed on the edge so that it doesn't have to consume the bandwidth. What that means is that your edge devices must become smart and generate and extract the meaningful information from the data that is being generated and reduce the information that needs to be transported by a factor of 1,000,000 or 1,000,000,000 or maybe more. A good example would be, let's say you have a camera that senses if somebody is about to break into the factory or the building or the house, and only at that time it'll send the information to the control center or sound an alarm. And the rest of the processing is happening on the device. There is no communication with any other server until that point. And that can easily reduce the bandwidth requirement by 1,000,000,000. So 10 to power 9 factor right there. And there are other reasons that I don't want to go into the details because of the shortage of time. The current development process is somewhat like this. You need 5 different skill sets. So you start with the setting of the hardware, you bring on gateway software, you acquire the data, train the model, develop the application, you compile the app, and then you flash the application into the app, then you monitor the device. So it takes skill sets ranging from a hardware engineer, a software engineer, a data scientist, embedded developer, and an IoT engineer. So what we did, we actually we automate most of these steps in our platform and called cAInvas, and there would be a lecture on that, hopefully next or the week after. Mr. Arnav will provide the information as to how to use that. And we will use that in every lecture to get familiar and use it to create a device that is smart enough, right? So that's the current development process, and we are working to automate most of it. Now, let's look at a short video as to what cAInvas can do.
Meet Mary. Mary is mute. She learns about a pre-trained AI model that can convert sign language gestures into spoken words and sentences. Mary finds cAInvas that lets her put ML model into sensory board. She creates wearable glove speaker. With that, Mary can speak to anyone she likes. cAInvas is an online development environment to put ML models into edge devices, including mobile, Raspberry Pi, and Arduino. It lets you update, visualize, train, and compile ML models with Python, C++ notebooks, easily shareable with the world. So, bring out your favorite device and choice a pre-trained ML model and make your device a smart device. With cAInvas DIY projects, you can make your home smart with applications like smart switches, listening to your voice command, smart door ajar alerts, and smart lights. cAInvas supports framework including TensorFlow, PyTorch, Keras, and DeepC. Check out free platform at cainvas.ai-techsystems.com.
So that was a tiny teaser for our platform cAInvas, and we would use that in our coming sessions. And so if you want to identify the kind of AI, you would look at into inputs, architecture, and output, and that categorization is not clear when you read the news articles and other things. So it helps that you have this knowledge of identifying what kind of AI or ML model has been used. We will cover some of that in our upcoming lectures. AI technology. So this is what you would end up learning, right? So again, this is a classification, and you have AI, which is which encompasses machine learning, and deep learning is part of machine learning. So, and these are the networks and models that are popular today, and we will go through some of those in this course. Machine learning foundation, very important slide. Essentially, if you want to know the entire stack, there's a huge amount of uh, theory and applications and libraries and developer framework and delivery mechanisms that you need to familiarize yourself. We will cover some of that. And not everybody needs to learn all of this. If you have mastery on one of these topics, it's easy enough to find a job in machine learning or start working on your project. Like I said, we would use a number of languages and framework on our platform cAInvas and show you how to develop that. And this is what our cAInvas platform looks like. If you have not signed up, go ahead and sign up now. This is the URL that would give you the access. And if you go and register yourself, we would use this platform to show off some of the models and languages and starting from scratch, like Python. So we are starting from Python. Some of you may have experience on using that. You guys can skip that first lecture if you like. But we will quickly move on to frameworks like NumPy and DeepC. And that's where you need to be attentive and learn. Like I said, it would require a good amount of time from you. With that, let me hand the meeting over to Mr. Gunjan. Gunjan, you ready?
Yeah, hi everyone. I'm Gunjan. I'm an engineer at AITS. I will be going over the introductory course on Python.
Gunjan, do you want to start your camera? Or
Yeah.
Let me know if you're able to present.
Can you guys see my screen?
Yeah.
So quickly get on with the Python 3. So this is the presentation outline that we will be going through today. Overview, data types, control structures, input, output, functions, file handling, exception handling, modules, classes. And let's start with the overview. So Python is an interpreted language. You don't have to compile to run a Python code. It is interactive and it supports OOPS, and it's a beginner's language. So it is great language for beginner level programmers. So there is a history of Python. It was developed by Guy van Rossum. And there were multiple versions of Python before. So Python 1, Python 2, and we will be mainly using Python 3. So these are the key changes coming from Python 2 to Python 3. So skipping these slides for now, as we are running short on time. So these are Python features that it is easy to learn. It's portable, extendable, scalable, and it has a massive library support. It supports major commercial databases. It supports OOPS, and you can develop GUI application. It has garbage collection, automatic garbage collection, and it can be easily integrated with C++, Java, and C. So getting on with the Python syntax. So unlike the C and C++ or Java, we don't use curly braces in a code block. We will be using indentation. So as you can see, if true, we are getting into this code block, else we are getting into this print answer. So we'll be using terminating the definition with colon, and we can use semicolon as optional at the end of the statement. So printing hello world is very simple. print parenthesis, and in the quotation mark you can give any string and it will be printed. So this is how you can comment out a code line. This is a single line comment out syntax, and this is a multi-line. So if you are giving 3 quotation over these lines, it will be commented out. Python files have extension of .py. So these are variables. These are dynamically typed. You don't have to declare the data types for variables. Like you can see, this is an integer data type. This is a float, and this is a string. This is a null value. So you don't have to declare the data types for any of the variables. You can declare all of the variables at once. Like if you want to store 1 at A, B, and C, you can do it like that. Or if you want to store 3 values in 3 variables, you can do it like that. A, comma B, comma C equals 1, comma 2, comma John. Going with the next Python data types. So first going with the number, these are immutable objects. So these are the data types that Python supports: int, float, absolute, comparison, exponential, logarithmic function, and power. So now the strings. Strings are immutable, so you cannot change their values. And change. So Python accepts string with single, double, triple quotation. So every string starts with 0. You can see the indexing here, 0 to 5. And if you are going in the reverse order, go with the -1 at the end and all the way over to -6 at the first, because this is a 6-character string. So going to the next, this is a string formatting. If you want to print your variables inside the print function, print statement, you can use the curly braces and use the format function to pass on the variable into that quotation, into that curly brace. Sorry. So we have common string operators. We have concatenation. You will be adding. You can add 2 strings. Like if we have hello over string over variable A and Python over variable B, if we do A plus B, it will give us hello Python. If we give this a repetition operator, we will have A star 2, it will give us hello hello. This is a slicing operator. It can cut out any of the character from a string with given index. So A of 1 will give us E, because in the hello, the indexing starts from 0, as I told you earlier, 0, 1. So E will be fetched out, and the -1 will fetch out O, because in the reverse indexing order, it will fetch from the last. So there is another slicing, that is a range slice. It will give you substring of a string. So let's say A1 colon 4. So 1 will be starting from E, and 4 will be ending on O. But slicing operator works as start and end. We will not take the end character of that string. So we will have E double L. So membership returns true if a character exists in a given string. So if you are wondering if H is contained in that string, so if you do H in hello, it will H in A, it will give you true. Let's these are the string methods that you can see. I will be sharing the slide link in the Discord server, so that you can go over to these methods if you want, because we are running short of time. Let's get on to the lists. So lists is a ordered group used for grouping the elements in a data in a mute. Sorry. So these are mutable objects that are used to store and order the stored um, the numbers or values. Sorry. It can contain any of the heterogeneous values. It can contain the numbers, float, strings, and any of the data types you want, like tuples, dictionary, everything. So a list indexes start from 0, and it ends at the -1 at the end with -1. So similar to the strings, we have slicing and range slicing operator over lists too. We have concatenation, repetition, and membership too. So let's see an example. We have a list of strings and integers over here, as I told you earlier, it contains heterogeneous values. So print list of item of index 0. So at index 0 we have physics a string over here, so it will be printing physics. So list of 1 to 4, range 1 comma 4, so it will print chemistry 1997 and 2000. Because 4 is 2015, it won't print the last element that you are passing of the index. So list 2 will print the list 2 if you are changing one element in the list. As it's mutable, it can be changed, unlike tuples, strings, or other immutable structures. So you were adding 1999 instead of 1997. Now if you are printing a list of element 2, it will print 1999. So you can also delete an element from the list with del list of 4, index 4, that will delete the element. You can see in the below, if you print the list, you will get only 4 elements instead of 5. Let's get on to the next slide. So list also has member functions like comparison, length, max, min, list. So you can see those whenever I'm going to give the slides to you later. So these are list methods: append, insert, count, index, remove, reverse sort. Let's say an example. Um, okay, so this is an list comprehension example. So if you have a string list of 1, 2, 3, if you want to uh, power generate the power of each element of 2, you can do x star star 2. This is the power of, operator. For x in a, it will generate a list of 149, that's squared elements of the list a. So like this. Next is tuples. These are immutable objects, unlike the list, which was mutable. So once assigned, you cannot change any of the values inside a tuple. So you can access the elements the same way you were accessing in the list. Like if you have 3 elements in a tuple, you can access the first element as T0. But you cannot assign values to an element that already has been declared, like this. So if you are assigning any values to T0 that already has been assigned as tuples, you cannot do that. So it will throw an error. So tuples are faster to protect your data against accidental changes because these are immutables. Um, so, so the tuples indices have the same methods as and operations and functions that we had for the lists. Next, we have the dictionary. So dictionary is like a hash map for C++. So it contains key value pairs. So dictionary will be enclosed with curly braces. We will be having key colon separated by colon and values over in a dictionary. So to access any of the values of the dictionary, you can pass the key within the square braces of the dictionary. For more example, let's go to the next slide. So we have declared a new dictionary called dict. We have key of name and value of Jude, key of age and value of 9, key of grade and value of 5th. So we want to see what is the value of name of the dictionary. So we will pass the dictionary name, and in a square bracket we will be passing the key of name. So we will be getting Jude as a result. So if you can see the output, dict name equals Jude.
Gunjan,
Like, yeah.
here I would like to remind you that we are left with just 10 minutes.
Okay. Okay, so I will make it fast. So these are how the dictionaries work. Let me quickly get on with this. Okay. So these are conditional statements: if, else, if, elif, else. These are just like any other programming language. You will know once you start coding. Loops. So you can loop over in with for and while loop. So for loop works as it works as a range, or it works as list or tuple or anything. So it will generate all the outputs based on the list that you pass. And these are break, continue, and pass statements. Break breaks the loop. Continue will skip the loop where you uh, uh, give the continue statement, and pass will pass. You do not want to execute any command in this code, so you will need the pass statement. Python functions. So we will be going through the functions. This is a standard method, standard syntax for defining any function. The this is a function name, and these are the arguments. These are required arguments. So keyword arguments are when we are passing age equals 50 as the name of the function parameter. So age is 50 and name is Alex. It doesn't matter what is the position of the variable arguments you are passing while you are naming the keyword of while passing the variables. And these are default arguments. You can check on with these later. These are variable length arguments. This is a star operator. You can pass on any number of arguments there. It will take it as a tuple. Next, file handling. We have mainly three access mode. This is a read, this is a write, and this is append. And after opening a file, don't forget to close the file because after closing the method flushes any unwritten information of the file. So reading a file, we can use read to read the whole file at once. Read lines. Exception handling. We have try, except, and finally, like any other language. So try tries a code block. If it fails, it falls into the except portion. If it doesn't, it breaks out the it skips the except portion, and the finally portion is executed every time, like no matter if it fails or passes. Python modules. We will be skipping this part as we have less time. So Python have object-oriented structure. We have classes. These are the constructor of Python. These are called dunder methods with double underscore over two methods like init. And you can declare object of that class and use that class methods like any other language, object-oriented programming language. So these are standard methods of get, has, and set attribute, del attribute. Data hiding, this is a Python feature. You can have a dunder method or not dunder method. You can have two underscores before a variable name. It will hide from outsider. So inheritance, you can pass a class object to another class and it will inherit from that above class. This is a standard oops feature. So I'm skipping that too. Okay, so I think we are at the end of Python. We have some codes for Python versus Java here, which is not necessary. Some useful tools where you will be writing codes. We don't need that because we have the cAInvas platform. These are the frameworks. These are the companies that uses Python. And these are the references that were used to make the slides for on SlideShare. So that will be all for Python. Let me quickly give you an overview of Jupyter lab. So this is a standard Jupyter notebook that we will be using. So let's start a Jupyter notebook server. Rohit, how much time do we have?
Another 5 minutes.
Okay. So this is the standard Jupyter notebook that you will be using while running Python codes. Let's start with hello world, the simplest Python code. So we have written the code for hello world. This is a run button. It will run the code. So you can see you can run any code snippet inside any code. These are called code blocks, and you will be running snippets here. So if you want to rename the file, let's rename it. So let's declare a list. Just going over what we learned before. So this we declared a list. So if you want to use this run function, you can use that. I am using shift plus enter. It's the same thing. So I will be accessing this two, like the second element from the list. So I will be doing index one. This is a slicing operator. This is the range-based slicing. So we will be getting starting from 0, like from 1, we will be getting till until 2. We will stop there. So a of 2 is 3. but we will not take that. We will take till 1 comma 2. This is a sample list. We can see the same thing with tuples. You can see what a data type it is using type is a tuple. And if you want any help of um, any object, you can pass on help and it will show you what kind of object it is, and it will show you all the methods that you can use. So this is the standard Jupyter Notebook version. I think you are already familiar with that, but I'm showing this because it's integrated with our cAInvas platform, which we will be using extensively in our later course. With that note, I'm going to end my Python and Jupyter Notebook tutorial. Hope you can have many questions. So we have that Discord server. You can share your questions here, general questions, lecture questions, and Canvas questions. So for now, if you have any general queries, you can paste them over here. If you have any queries related to the lecture, you can paste them here. Rohit, I think that would be all from my side.
Thank you, Gunjan.
Yeah.
So, yeah, that was, thank you so much. It was a beautiful, wonderful, concise, short on Python. I hope you guys got something out of that. And like I said, we would go at a faster pace because there's a lot to cover, and we expect you guys to, um, you know, put in work after these lectures are over. These are barely going to cover what you need to know, and you will have to, find time to go through these lectures in detail and possibly practice. So, for every 1 hour that you spend online, I'm expecting 4 to 6 hours offline minimum. If you're an expert, otherwise another 16 hours, I would hope. For somebody who doesn't know Python, it would take some time. So if you want to catch up to the next lecture, you need to be at least on the beginner status before we get into and deep dive into deep C and other things. So like I said, the future is exciting. I am excited to work with you guys, rest of our team, including Mr. Arnab, Gunjan, and Mr. Xavier. You have any question, please do ask it on the Discord server. And I'm sure many of you are already experts in some of these things. So help your mate out. Answer the questions for them. And that way we can, make progress, one bit at a time. And hopefully by the end of 6 weeks, we will have a component, a smart hardware device, a paper, a presentation, and a blog from each one of you that you can be proud of. That what you've done in 6 weeks is something worth carrying into the future, right? With that, I'm going to stop recording, and maybe we can take 1 or 2 questions